Hi friends, and welcome to the last section of chapter 5. This one's on factoring. Okay, remember I had mentioned when we were doing distributing that we would have a lesson that is the opposite of distributing or backwards distributing. We have found it. So I need to define one word first, and that word is a monomial. Monomial. Okay. The book definition says a number, a variable, or a product of a number and a variable. In other words, from the words that we've defined before, it means one term. Okay, mono meaning one. Get it? Get it? Okay, so examples of monomials could be 3x or 25 or 7xyz. Okay, it's all together with just multiplication. We could even have division in there. You could have a x over 7 or something, and that still counts as one term, so it's a monomial, as opposed to a polynomial, poly meaning lots, or binomial meaning two. Most of our linear expressions have been binomials or two. Okay, and so with that information, we're going to define factoring. To factor is to write a number as a product of its factors. To write a number as a product of its factors. So we're, pulling a number out of both of them. Like I said, this is the opposite of distributing. Okay, so those are our two words that we wanted to define, that I wanted to define. You probably didn't have a great desire for it. And then the last thing, or the step, one of the steps is, first of all, to find the greatest common factor. So we're going to find the GCF, greatest common factor. So this is the biggest thing that can go into both of your terms. Okay, now with algebra, you've done that with numbers. With algebra, we're going to throw in variables as well. So I'll show you what that looks like. Okay, so but we're not fully factoring yet, we're just finding the greatest common factor. So we've got the monomials 4x and 12x. Okay, now if you are really well versed with your multiplication tables, then it's pretty easy to see what number both of those can be divided by. If you are not well versed in your multiplication tables, let me show you how to do this. Do you guys remember in past years when they've made you do factor trees or prime factorization? So you get the factors down to the prime numbers. So 4 factors down to be 2 times 2. 12 can be, there's lots of them, so 2 times 6, and 6 is 2 times 3. So these are the prime factorizations. So we can write this out. 4x is 2 times 2 and then times x, right? Because the prime factorization of 4 is 2 times 2. And then we have the variable. The factorization of 12x is going to be, I think there's supposed to be a 2 in there. Okay, 2 times 2 times 3, and then times x, right? 2 times 2 is 4, times 3 is 12. Done. Okay, now to find the greatest common factor, we're going to circle the pairs of things that are the same in both. So we've got a pair of 2's, we've got another pair of 2's, and we've got an x. So the greatest common factor is going to be 2 times 2, which is 4, with an x. Okay, now you could probably just look at that and see that 4 is the biggest number that goes into 4 and 12. And then again, if a variable appears in both of them, it will be part of the greatest common factor. Looks like we're going to do one more of those. We're going to start with 12CD and 36CDE. Okay, now, instead of doing a prime factorization, I just know in my head that 12 goes into 36. So my greatest common factor is going to be 12. And then the variables that are in both of them are C and D. Okay? So if we wanted to, we'll leave it at that. Okay, again, if that was difficult for you, I will do the prime factorization. 12 we've already done out. So the prime factorization for 12CD is 2 times 2 times 3, and then times C and times D. 36CDE is going to be, 36 is 12 times 3, right? So that means we're going to have an extra 3. So that's the 12, and then times 3 gets us to 36, times C times D times E. So our matching, our pairs of things are like that. So 2 times 2, which is 4, times 3, which is 12, and then variables are C and D that match, that go into both. Okay, so the whole point of finding the greatest common factor is that then we can, if we have a binomial, usually we do this with binomials, so 2 terms, we can divide the greatest common factor out of both of them and then pull it out and put it on the outside of parentheses. Okay, so we're going to start with 3x plus 9. Now, looking at this, do we have a common variable? Nope, there's only a variable in 1, so we're not going to have a variable in our greatest common factor. Looking at 3 and 9, do we have a common factor there? We do indeed, and it's 3. So our greatest common factor is 3. This is the number then we want to put on the outside of parentheses. Then we're going to take each one of these and divide it by 3 to find out what goes on the inside. So 3x divided by 3, 3 divided by 3 is 1. So we just have 1x, which we don't write the 1, ninja 1. So it's just x. And then 9 divided by 3 is 3. And then you can check this by distributing the number that you have on the outside back through to see if you get the same thing. So 3 times x is 3x, and 3 times 3 is 9. And look at that, it matches. So that means we did it right. Okay, but really with factoring, knowing your multiplication tables makes it so much easier. So maybe that's something you want to practice on your own. Okay, now here's an example of an exciting thing that can happen. 12x plus 7y. Okay, do we have a common variable? Nope. Do we have any common factors between 12 and 7? Let's do a prime factorization of these just so we know. We've done 12. Prime factorization of 12, or we can even do 12x, is 2 times 2 times 3 times x. Prime factorization of 7y, well, crazy thing, 7 is prime, so we just have 1 times 7 and times y. Is there anything that matches in there? No, there is not. Therefore, there is no factor we can pull out. We can't factor this at all. So you can just put the empty set saying, nope, that is not, there is no solution to factoring that situation. Sometimes it's fun to be able to say no, right? All right, here's another one. 4x minus 28. All right, let's see if we can find a common factor. First of all, it's probably good to check to see if one of the numbers goes into the other one. In this case, it does. 28 divided by 4 gives us 7. So our greatest common factor, we don't have a variable. Friday bells are fun. Okay, we don't have a common variable, so we don't have a variable in our greatest common factor. And then because 4 can go into 4 and 4 can go into 28, 4 is our greatest common factor. So I'm going to put that 4 on the outside of parentheses. 4x divided by 4 is just x. 28 divided by 4 is 7. Okay, and that's it. We factored it. Ta-da! And it doesn't look like they're going to mess around too much with negatives, which is nice. Factoring can get a little bit sticky when negatives are involved, but I don't think you have to deal with that. That's a next year you problem. This year we're just going to do the basics, which I like. Okay, here's another one. 3x plus 33y. All right, do we have a common variable? Nope. Greatest common factor, so we're not going to have a variable in our greatest common factor. And it's pretty easy to factor this one, right? I hope you can see that, because 3 can go into both of those. So we're going to put that 3, that greatest common factor, on the outside. And 3x divided by 3 leaves us with x. 33 divided by 3 is 11, and we keep the y. Ta-da! And right. Ooh, now this one's trickier. This one's got some interesting, lots of it. I think I probably made this problem up on my own so that we had a challenge. Okay, 12xy minus 20xyz. So let's find our greatest common factor. Okay, let's think. What can go into both 12 and 20? Okay, 2 can, but I think there's a bigger one than even that. I think 4 can go into both of those. 12 divided by 4 is 3. 20 divided by 4 is 5. 3 and 5 are prime, so we're done. So the number-wise, the greatest common factor is 4. And then looking at the variables, which variables do we have in both? We've got an x and a y in both. Okay, so then if we go ahead and factor this situation, we're going to put our greatest common factor on the outside, 4xy. Oops. And on the inside, 12xy divided by 4xy. The x and the y cancel out because x divided by x is 1, and 1 times anything is itself, so we don't have to write it. Same thing with the y. 12 divided by 4 leaves us with 3. And then over here, 20 divided by 4 is 5. Oops, sorry again. It's been 3 minutes since the last one. Then the x and the y got pulled out, and we're left with z. Okay, and again, you can always multiply this term back through to make sure you get back to where you started. Okay, and then the last one I want to do with you, because there's several story problems on the assignment, so I kind of want to explain to you what those look like. So you can see the story problem here with me. It says the drawing of a garden at the right has a total area of 15x plus 18 square feet. Find possible dimensions of the garden. Really what this means, let me interpret these story problems for you, because there's like 4 of them. What you're going to be doing is just the total area is this thing, and we're just going to factor it to find possibilities for what times what will give us this thing. So in other words, we just need to factor 15x plus 18. So I'm going to put on the paper 15x plus 18. Okay, so let's find our greatest common factor. My guess is 3. 15 divided by 3 is 5. 18 divided by 3 is 6. There are no common factors in 5 and 6, so 3 it is. And we don't have an x in the second one, so no variable. So we pull out a 3, and what's left on the inside is 15 divided by 3 is 5 with an x, and 18 divided by 3 is 6. So this means in that garden, the possible dimensions are 3 and 5x plus 6. Because if we multiply those together, we get our total area. And I think most of the story problems deal with that, or they just give you a binomial and it tells you to factor them. So give it a try. Factoring can be a challenge, but I think you guys are up for it. Good luck.